Hello and welcome to week 11. In this week, we will be focusing whole our discussion on Turboshaft engine. This is our lecture 55. Let's see what all we were discussing in last week. The last week it was dedicated for the turboprop engine, where we have discussed the introduction about the turboprop engine. Then we started discussing in terms of advantages and challenges for the turboprop engines. We also have discussed about the thermal cycle analysis of single spool and two spool turboprop engine. Then we tried to compare turbojet engine, turbofan engine and turboprop engine. We also have discussed the effect of various cycle parameters on engine performance, especially for the cruise condition. And that's where we have ended up with the turboprop engines. So you can understand these engines, what all we are discussing, they are gas turbine engines. They are having a special mission, special requirement. If we discuss in terms of turbojet engine, we know the whole purpose, it is for the generation of the thrust. Similarly, if we are talking about say turbofan engine, there also we are generating our thrust, but there we have thrust, that's what is because of say cold thrust and hot thrust. Cold in a sense thrust, that's what is generated by the fan exhaust, and hot thrust means thrust, that's what is generated by our core engine. Then we were discussing about the turboprop engine, where the whole thrust we are focusing based on the propeller. So basically propeller, that's what was generating the thrust, and we have seen the research and ongoing application that shows thrust generated by the propeller as well as by the exhaust of the engine, gas turbine engine. So we were having say two thrusts, that's what were coming. One, it is because of propeller, and second one, that's what is because of exhaust from the nozzle. Now just think of gas turbine application in a different way, where my focus is not for the generation of the thrust. The focus is for the generation of power, and that power we say as a soft power, and that soft power, that's what is having number of applications. So this week it is mostly dedicated in terms of discussion for the turboshaft engines. So what all we will be discussing, that's including say turboshaft engine introduction, advantages and challenges of turboshaft engines. We will be discussing various applications of turboshaft engine. Then we will be doing the thermal cycle analysis for the single spool and two spool turboshaft engine. We know prop fan, that's what is a recent trend. So we will be discussing the thermal cycle analysis for the prop fan, because that's what is of major interest. And we will be start making the base for our next week discussion based on what all are the requirements of subsonic aircraft schedule. So this week we will be focusing on the turboshaft engine mainly. So let's try to look at what all we know. So here in this case, if we look at, we have our idea in terms of say thrust generation. So this we can say it's a cut section, that's what is representing say our turbojet engine, where the working principle for all the engines, that's what is same. We are having intake, that air it will be getting inside the compressor, where will it get the compression. Then after we are having combustion chamber, where the fuel and air mix, and that will get burned. That will be generating the flue gas, those flue gas which are we are using for the rotation of the turbine. Basically this turbine and compressor, they are on common shaft. So by rotation of the turbine, the compressor will be rotating, and at the exit we will be having sufficient amount of heat. We can say the gas which is coming out from the turbine, it is having more amount of enthalpy, temperature. That's what we were converting in kinetic energy by using this nozzle, and that's how we say this exhaust of the nozzle, that's what is generating the thrust, and the thrust we have discussed, that's what is given by this formulation. Then we have looked at our turbofan engine, as we have discussed earlier, where we are having two thrust or two component of thrust that will be coming into the picture. The thrust component because of fan exhaust, and thrust component because of my core engine. Similarly, we have discussed about the propeller. So, now let us look at the second kind of configuration. Here if we look at the construction seems to be same, but here in this case we have some difference that can be seen clearly. What is the difference? Here if we look at, we are having one shaft, that is what is coming out, and this shaft we can say that is what is say shaft power. Now, this shaft power we can use for different purpose, as we have discussed in last week also. We can connect the generator with this shaft, which can be used for the generation of electricity. We can connect this shaft for the propeller. So, that is what will be used to rotate the propeller. So, that we have defined as a turboprop engine. We can also rotate some kind of rotors, and for the rotation of any mechanical component you need the power. In construction, if we compare here, we are having decreasing area kind of construction, that is what we say as a nozzle, and here in this case exhaust, that is what is a constant area duct. Okay, so we can understand the purpose of this engine, that is what is not for the generation of thrust. The purpose is for the generation of power. So, let us look at what all we have understood here. So, this is a single spool turboprop engine, where we have discussed say compressor and the propeller, they both are rotated by using say turbine, and that turbine we have defined as a gas generator. Okay. So, here we can say we are having some amount of power, that is what will be coming out from this shaft, which was used for the rotation of the propeller. Similarly, we have other construction in which we have two spools. One spool we can say the compressor, that is what will be rotated by HP turbine, and other turbine, that is what we have defined as a power turbine or free turbine, which is connected with the propeller by using say gearbox, and that is what is used to rotate the propeller. And we have seen here our propeller that will be rotating at the lower speed. There is a special reason we have discussed, that is what is in concern of the structure issues because of centrifugal forces, and we will be having higher tip speed if my rotational speed is higher, and constant diameter if we consider, we will be having the shock that will be forming near the tip region, and that will lead to increase the aerodynamic losses. So, this is what all about the turboprop engine. Let us discuss about this. So, we have this as a reference. Now, just think of like this engine what we have, it is connected with the gearbox, and that is what is connected with the propeller. In place of that, we will be using the similar engine here, and the power, that is what is coming out by this shaft, that is what will be connected with the bevel gear here. So, additional power, that is what will be generated by our power turbine or free turbine, that is what is used to rotate this bevel gear. Now, this bevel gear, it will be transferring the energy or power to this shaft, and that shaft it is connected with the helicopter rotor. So, here if we look at this construction is different from our turboprop engine configuration. The engines look same, but the thing is purpose, that is what is different. Now, these blades what we are looking at for the helicopter, they are connected with these vast plates, and those vast plates, that is what will be able to tilt the blades of this main rotor, and by that mean it will be changing the angle of attack. And the purpose of these blades, they are the aerofoil blades. The purpose is similar here, that is to generate the lift. Okay. So, you can say here we are not focusing on the thrust, here our requirement is for the rotation, and by rotation we are generating the lift, that is what will be giving the vertical takeoff. So, let us look at what all are the operations for. So, if we look at this turboshaft engine, that turboshaft engine it is connected with say bevel gear, and that is what is connected with the rotor. It will be performing different kind of movement, say forward movement, backward movement, sideward movement, even it can rotate. So, here in this case if we look at carefully how the tilting of my main blade, that is what is happening, accordingly I will be having forward backward motion, as well as the sideward motion. Similarly, in order to get the turn on the rear side, we are having another fan, that's what will be taking care of gyroscopic motion. This course is not dedicated for the helicopter. Those who are interested can go through YouTube videos where they are discussing about what all are the applications and how these helicopters are working. Our major focus is on engine. So let's move how these engines are placed with. So here if you look at, this is what is our gas turbine engine. You can see here this is the exhaust. As we have discussed, the purpose here, it is not for the thrust generation. So the exhaust what we are looking for, that's what is having some different kind of construction. You can understand the gas what will be coming out from this exhaust or say from this nozzle, that's what is at high temperature. So that should not impact on say main rotor blade or even say any component of helicopter, and that's the reason why it is having a special kind of shape. You can see here this engine, that's what is been arranged in such a way that it will be connected with the bevel gear and it will be giving say 90-degree rotation to this. Similarly, here if we look at, this is the placement of the engine. So this engine placement, that is also of area of interest and area of research based on what kind of application we are having for the helicopter, what is the size of our helicopter, where we will be using these helicopters, all those things, that's what will be coming into the picture. So here if we look at, this is clearly representing the open section of this gas turbine engine. You can see on the rear side we are having this exhaust. Similarly, here in this case we can see swash plate clearly, that's what is connected with our main shaft. These days people they are talking about say use of this gas turbine engines for special applications, say for UAV helicopters. So this is the engine, it has been specially designed where it will be generating the power rather generating the thrust, and that's what is connected with the bevel gear, and here it will be connected with the helicopter. So we will be discussing all these things very soon. Let's see what all are the other applications of this turboshaft engine. You can imagine now what all we are discussing is not related with the thrust, it is mainly related with the power. So people they found their application of this turboshaft engine. So here if we look at, this is representing say Rolls-Royce MT7 marine engine. Now you will get surprised that gas turbine engine, these engines what we are discussing, they all are aeroderivative gas turbine engines. What is the meaning of that aeroderivative? That means these engines they are initially been designed for aircraft purpose, and later on the same engine they are using for the purpose of say power generation. So here in this case this is connected with the hovercraft. If you look at carefully, this hovercraft shaft, that's what is connected with this gas turbine engine, and that's what will be giving the high speed to be achieved by this this hovercraft. Similarly, here if we look at these engines, they are also having marine application. So for this is the Royal Navy Queen Elizabeth carrier. So you can imagine lot of aircrafts they are placing, that's what is moving, and that required huge amount of say power in order to propel. So under that condition you can imagine if we are using say reciprocating engine, say marine application, if we look at most of the engines they all are diesel engine, internal combustion engine. When my power capacity requirement is huge, my size will be increasing, and if my size will be increasing, that's what will be putting additional weight to the carrier, and that's the reason why they are looking for say compactness of the engine. So here very important term, that's what is coming into the picture, that's what is called power to weight ratio. So this gas turbine engines they are having power to weight ratio to be very high, because its weight is lower compared to your internal combustion engine, and that's the reason why people they started applying these gas turbine engines for this special marine applications, where they are able to achieve high speed. That is also a major requirement. So, load requirement, power requirement, speed requirement, all this together, that is what has attracted the attention for this engine to be used for marine purpose. So, here if we look at this engine, it is a Kabini engine, it is aeroderivative engine, say GTRE India, they have developed the engine that is named as say Kaveri engine. That Kaveri engine, it is for say fighter aircraft. Parallelly, they started working on the development of the second engine, that is aeroderivative. So, you can imagine for fighter aircraft, the requirement is say you need to have your afterburner. So, here in this case, they have removed that afterburner, they have done certain modification in the engine, and now this engine is fit for the application for the marine, and mainly that is what is for navy. So, you can imagine not only for the navy, but for your conventional shipping purpose also, people they are slowly moving towards the gas turbine engines. Okay. Here if we look at, this is GE-LM 2500 marine engine. So, it is aeroderivative from CF6 aircraft engine. If you recall, we have discussed about say turbofan engine. So, same logic, that is what is been applied here. So, they have converted that engine for this marine application. So, now you can imagine you are suppose say aerospace engineer, you are mechanical engineer, you are electrical engineer, and you are thinking of application of gas turbine engines. This is a different kind of flavor, that is what is giving. When I say turboshaft engine, you are having the application, these are the special application. These engines also have application for the power generation. So, what gas turbine power plants we have around the world, they are also working on a similar principle. So, the purpose is to generate the power, shaft power, and that shaft power, that is what is connected here. In this case, they are connected with the propeller. For marine application, that is what is connected with the main rotor through bevel gear for helicopter. If it is connected with the generator, then that is what is named as a power generating unit, or we can say it is a power plant. Okay. Now, let us look at other applications. So, here in this case, if you look at, there are two tanks say T-80, that is what was developed by Russians long back, and that is what is using say gas turbine power plant. So, you can imagine the applications what people they thought of. This was developed during 70s and 80s. Similarly, here if we look at, it is M1 Abrams, that is what is American battle tank, that is also having gas turbine power plant. So, if we look at carefully, this is representing the cut section. Now, the question will come, say why are we moving towards say gas turbine engine? There are special requirements by the military. The requirement is in terms of say maybe fuel economy, their requirement is in terms of power to weight ratio, their requirement is in terms of having the high speed, they are looking for say more weight carrying capacity, all those things, that is what is attracting the application of the gas turbine engines for such applications. You can imagine these tanks, they are moving in say desert area. So, there they need to go with the specialized filtering devices. So, there are challenges to be used for these gas turbines for these applications, but it is not limited to the aircraft, it is not limited to helicopter, it is not say limited to the marine application. They have a lot of application, people they are finding ample of applications with this. The compactness, that is what is a major attraction for the gas turbine engine, and that is the reason when I have started with the course, I told this gas turbine industry, that is what is multi-billion-dollar industry, and that is what is a major focus for many countries, and that is the reason why major universities in western countries they are having the specialized course on gas turbine engines. Okay. Now, let us look at the other applications. Here if we look at, these are the application of turboshaft engine for UAV helicopters. So, here if we look at these two UAV helicopters like unmanned little bird and Northrop Grumman, they both are run by using say Rolls-Royce 250 engine, Ellison Rolls-Royce 250 engine. Here if you look at this engine has a different kind of construction. Just look at here we are having axial flow compressor that will be followed by centrifugal compressor, and from there all the way flow, that is what is going here. It is a single can type of combustor, that is what is used to rotate the turbines. This turbine they are rotating the compressor, both the compressor like axial flow compressor as well as centrifugal compressor, and this is what is a power generating unit. We can say it is a power turbine, and from here you are having the exhaust. So, like there are special kind of construction also. So, it is not always necessary that you will be having the construction that will be followed by compressor, combustion chamber, turbine and then nozzle. Here it is an exceptional case. Similarly, if we look at this is representing hummingbird helicopter. So, it is a UAV helicopter, that is what is being run by a Pratt & Whitney 206-207 engine. That is what is having construction of say centrifugal compressor that will be run by the axial turbine, and the power turbine that is what is connected with the propeller say this shaft, and this shaft that is what is connected with our rotor of the helicopter. So, the engine making companies they are not limiting themselves with the development of engines like turbojet engine, turbofan engine or turboprop engine. They are extending their applications. There are many specialized companies they are having expertise in turboshaft engine. So, here if you look at these are the special kind of engines they are being used for a specific purpose. Now, here if we look at this is a interesting part, it is a DAS, that is what is being used for anti-submarine helicopter, and here if we look at this is representing T50 turboshaft engine. Okay. If you recall we have discussed similar kind of engine even for turboprop engine, then you will be having say understanding say turboprop engine also can be used as a turboshaft engine. Yes, but you need to do certain modification or maybe no modification. In turboprop engine the thrust what we are discussing that will be generated by say your propeller as well as by the nozzle. Here in this case we are not bothering of the thrust. Similarly, here it is representing Kamam K Max where they are having two helicopter engines, they are Honeywell engines. So, now if we look at the construction, it says axial flow compressor that will be followed by the centrifugal compressor, reversible combustor, then we are having axial flow turbines, here we are having power turbine. So, the compactness that is what is a major requirement, and that is the reason why we are having such kind of engine configurations. Okay. Now, let us look at how exactly these engines are. Say here in this case we are having axial flow compressor that will be followed by the centrifugal compressor that will be run by the turbine. So, here they all are on common shaft. Then we have power turbine, it is not connected with this main engine, it is a separate shaft. That shaft is connected with the power output shaft. Similarly, here in this case if we look at we are having two centrifugal compressor that will be followed by say this turbine. So, this turbine mainly that is what is rotating these two compressors. On the back side we are having the free turbine. This free turbine it is having a shaft inside, it is going inside, and that is what is connected with the power output shaft. Okay. So, now let us look at what all are the advantages of turboshaft engine. So, this turboshaft engine we know that is what is mainly for the power generation purpose. So, comparison that is what will be coming mainly with say the power generating units like say reciprocating engine, and that too it is a diesel power plant. So, here in this case for turboshaft engine my power to weight ratio that is what is very high, and that is the reason why it is attracting the application for helicopters where we want to lift heavy loads and it need to operate efficiently. Similarly, the reliability of these engines they are higher because it is having say fewer moving component compared to your reciprocating engine, and that's what will be reducing the chances for the mechanical failure, and it is simplifying the maintenance compared to our internal combustion engine. They are compact in design, and that's where the application that will be coming for say helicopters and for small aircrafts. It is having say constant power output. So basically these helicopters, they are flying at different altitude where they want the rotor that need to rotate at the say constant speed under different flight operations, and this is the engine that's what will be providing that requirement. Here in this case we are having say fuel efficiency that will be more compared to the piston engine, as we have discussed. The high altitude operation, that's what is a major requirement where we have limitation with the internal combustion engine. So there we need to move with these turboshaft engines, and these engines are quick startup. That's what is a basic need when we are talking about the emergency and critical missions. The vibration, because we are not having many reciprocating components, and that's the reason why the vibration is lower compared to what all we are discussing in terms of our mechanical engine. That's what is internal combustion engine. Now it's more versatile. We are having, as we have discussed, a number of application. This can be used for say helicopter, that can be used for marine application, for power generation, pump. It can be used for running the equipments where they are mainly working as a main primary propulsion device. The noise generation by these engines are less compared to the reciprocating engine, and that is what is a major attraction for the tanks, because lot of noise, that's what will be coming out when we are having say our reciprocating engine. So for medical operation, for urban transport, that's what is a major requirement. Same way the maintenance requirement, that's what is less, as we have discussed. It is having greater power control. You can have smooth control of this power as per our requirement, and that's the reason why it is a major attraction for the helicopter application during takeoff, landing and hovering. Now let's look at what all are the challenges for this turboshaft engine. These engines, they are gas turbine engine, so you can say they are the most complex engine compared to what all we are discussing in terms of our reciprocating engine. And since they are complex, that's the reason why the manufacturing cost is more, maintenance also will be expensive. When we are talking about the maintenance, then they need a specialized skilled person to handle the maintenance, and that's what will be costlier affair. Okay, this regular inspection and maintenance, they are the crucial requirement in order to have safe and efficient operation. When we are talking about the fuel consumption, this fuel consumption, it is less compared to say reciprocating engine what we are discussing, but when we are comparing with the other gas turbine engines, it's say little poor when we are talking about small helicopter engines. The weight what we think of, it is comparable with the reciprocating engine, but at the same time when we are talking about say aero application, then this load is very high or weight is higher, and that's the reason it is putting restriction for the application of say aircrafts and helicopters. Now we are flying at altitude. When we are moving upwards, we are having say thinner air, and that's where we are having the limitation in terms of say higher altitude application. So mainly for military purpose, this is what is a major requirement. At the same time, since it's a gas turbine engine, so temperature will be very high for the components as well as for the exhaust. So that's what is required, special kind of attention, and that requires a special kind of cooling. So the placement of this engine, it matters a lot. Same way when we are discussing about the noise level, as we have discussed, the noise level, that's what is lower compared to other engines, but when we are talking about the urban environment as well as for say special application where these helicopters, they are making a lot of noise. Okay, and power to weight ratio, as we have discussed, like in compared to our reciprocating engine, they are the best, but when we are comparing with the turbojet engine, this is having a trouble in terms of higher, say, power to weight ratio for the jet engines. Okay. And this all in summation, if we look at, we can understand this turboshaft engines, they are having a special kind of applications. They are the specialized engine and they have to perform specialized work. So, with this introduction, here we are stopping with. If you have any query, you just go through the working and operation of helicopters. There are YouTube videos which are discussing about how these engines are working, how the rotors are working for these helicopter engines. So, in next lecture, we will be discussing the thermal cycle analysis for this turboshaft engine. Thank you very much.